Good morning, everybody. Welcome back to Coding on Swiboe, the next generation text editor, or as I like to say, the text editor for the second half of my career. Top of the show business, we have a little bit of stuff that I want to talk about. So first, I checked in the icons that I showed you yesterday. So Swiboe now has a really nice icon also in the README. Here, really nice, really nice, really nice. But that's it, nothing more. More importantly, actually, I decided on a license yesterday. I was unsure if I wanted to license Swiboe under MIT or under Apache 2. I went with Apache 2, but basically they are both super permissive and basically say do whatever you want with Swiboe as long as you mention the Swiboe development team. Apache 2.0 does not allow you to use Swiboe in anything that is patented, which is basically I don't like software patents. That is why I actually went with Apache. And then yesterday evening I had a really nice pairing session, a remote pairing session with Greg. That was really cool actually. Basically, Greg got interested in Swiboe and he did a bunch of code reviews for me so far. And we always said, oh, we should pair someday, we should pair someday. And yesterday I was thinking about how to combine all the errors, or if all the error types that are in Swiboe right now, if there should only be one error type, and how we can actually combine them into one type. And then I just pinged him on Gitter and he was available, and then we paired over Google Hangouts and Flubits. It was really nifty. I'm not associated with Flubits in any ways, but you folks should really try it out. It is awesome. At some point we were actually like, it would be cool if you could see my my terminal as well. And then we realized that they actually have support for that. It's really awesome. It seems like they use that a lot. Shriek, no, this is actually not a pair programming stream with Greg this morning. I would like to do that in the future, but for now, it's just me. Now, yeah, and this is actually the branch that came out of it. It doesn't compile yet, but we made some progress. We actually looked through the standard library together and then decided that it would probably be best if we just try to unify the error types all into one and then not try to match exhaustively on all the error types that can be. And not sure how they will turn out, but we made some progress on that. If you want to have a look at this branch, it actually right now it doesn't even compile, but if you look at the diff, which I can do real quick, like so maybe. Yeah. You can actually see that we replaced a bunch of unwraps through tries, which is of course always the right direction, bubbling up errors instead of crashing. And we deleted a bunch of errors, and especially all the conversions from one error type into another error type, so that we only have one error for everything that is in Rust, and then one RPC error for everything that has to cross across RPC boundaries. And the last thing that happened this morning actually is this pull request from Severin, who is present today in chat. And he fixed a bunch of my broken English in the README, and I really appreciate that. I'm not a native speaker, and English is, especially prose, is really hard. So if somebody finds errors and reports them and fixes them even, that is absolutely great. And another thing that we learned doing that is actually when I tried merging that through Homu, when it ran our tests, the tests actually failed. So it turns out that our tests are flaky because this is not changing any logic, and the tests passed yesterday. Actually, they even passed on Travis. They only failed for Homu. So we have to look into that again. Probably one of the clients is disconnecting too early, or there's a race condition if one client disconnects first or the other client disconnects first. So eventually we have to look at that. That's all the top of the show business that I have. I think we can actually dive right in. What did I want to do today? Right, I remember now. We actually wanted to work on calling RPCs in the Python client. So right now we can connect with our client, and we actually can register RPCs, and then those RPCs can be called from Rust, which we've proven that by basically bringing up our Python client. We have the terminal GUI here. Down here the server is running. And if I press S in the terminal GUI, then actually our callback gets called. And right now it returns with an error, so the second callback doesn't get a chance to run. But that's fine. And now we actually want to go the other way, right? If we have already RPCs that are registered with the server, we would like to call them through Python. And we have to go on a slight tangent here, because in Rustland there are actually two things that can call RPCs. So first, our client. The client can actually call an RPC, and it gets returned a RPC client context. And on this client context, you can actually do stuff like cancel the RPC or wait till it is completed, inspect partial data that comes from the RPC, good stuff like that. But we also have something that is called a thin client. And we also have something that is called a RPC server context. Server here. And I think that has a client call too, right? Yes, so actually there are not two things, there are three things. So let me first explain what the thin client is. Basically, the client owns the connection to the Swiboe server, and there can only be one connection to the Swiboe server per client. So you cannot easily duplicate the client. So the thin client is essentially something that you can send to another thread that can also call RPCs. That's that, nothing more. And then we have the RPC context, and that is actually the one thing that gets passed into a RPC call. So if you implement a RPC that can be called from another process, once this is called, you actually get one of those contexts, so that inside your RPC implementation, you can also call out to other RPCs, right? Right. So the thin client, we can, I think we can ignore that for now and just pretend, because in Python land you can just pass around the client pointer and we can use that everywhere to do calls. So I think we can ignore the thin client. We only have to implement call for the client itself, and also for the RPC context, which is not wrapped yet. So basically, how this would look if you have an RPC that you implement, the first argument that it would get is actually a context. And on this context, you could actually do something like context, call, and then you could call another RPC, right? And in Rustland, actually, we also have something like context finish, which is essentially what we do here, right? We return a final value here from our RPC, and this is then passed to context finish. So if we also wrap the context, we might as well just also wrap the finish call, and then we can get rid of Swiboe RPC error and RPC OK again. I'm not sure how this design will look though once we're done with that. So let's start with the easy thing and basically just calling a RPC from the client. Okay. Okay. Let's change this code around a little bit. So we only keep the callback 1 around. We don't actually need to register any other RPCs. So basically we have a client. Oops, we never disconnect the second client. That seems wrong. So we have a client, the client registers an RPC, that is fine, and we have a client 1, and this client 1 should now actually call this RPC. So how should that look? It should basically be something like client 1 call test.test, And the arguments are dump something as a string, and the something will just be a dictionary. Foo is a bar, right? So this is how it should look. Though, of course, I mean, we're writing a C library, so there's no object orientation here, so this cannot look like this. It actually has to look something like Swiboe client call RPC. That takes the client 1 and then takes the rest of the arguments, like so. Okay, so what will this function look like? So it will be a Swiboe client call RPC. It will return, you know what, for now it doesn't return anything. Eventually it needs to return the client context so that we can also cancel RPCs from CLAN, but for now, no, for now no. Nope. The archetypes are, what does it take? It takes a pointer to a client. Yes, pointer to a client, and then it takes a string, and it takes another string, which are the arguments. And I think that looks about right. So we go now into our C client and we implement the function C client lib. Let's make this one correct. Swiboe client call RPC. Yes, and pointer string looks great. Looks great. Wow, what's going on? Please, keyboard, keep it together. Ah, okay. My keyboard was typing W's for some reason. No idea why. No mango. Poop extern C function. Swiboe client call RPC. And it takes, does it take a mutable or a const pointer? That's actually something that we can look up in what does the client need? So where's the client? The client call actually takes a const reference, so it is fine for us to actually also take a const pointer here. So we take a const pointer to client, right? Yes. And then the second argument that we take is, actually this is called client, surprisingly. And then this is called RPC name. And that is a const pointer to a cjar object. And what else do we take? And we take the arguments. That is also a const pointer to a cjar object. But that might also be empty, right? If we don't take if the RPC doesn't take any arguments, then this can be null pointer. I think. Maybe. Okay, and now we need to actually cast our client into some reference so that we can work with. That is, we can steal that from down here. That looks like this, right? So we get a mutable reference to our client. We take a mutable reference and not a box because we don't want to drop the client, right? We don't kill it here, we don't delete it. And then we need the RPC name. That is actually C_str to string, RPC name. And we have the arguments. I'm thinking that I have that already, right? Yeah, actually, here. That looks very much the same. We have the arguments, and if basically the arguments is null, then the arguments is none. Otherwise, we convert the arguments into a Serde object. That is correct. Yes, that is correct. And if that is not working, then the caller made a mistake, right? It passed invalid arguments and we crash. Because invalid arguments, programming errors, crash. Swiboe client call RPC, args not valid JSON. Very nice. Very nice. And now we can just do the call. Client call. Here it is. Client call. It takes the function, RPC name, and it takes the arguments, which are interestingly enough not optional. Okay, so basically what we need to say is we have to create an empty value object here somehow, something like serde JSON or serde value, something like this, new. And then it's always something, but not necessarily something interesting. And do we take that by reference? Yes, we take it by reference. Okay, I think that should be it. Basically what we get back here is a context, and this context allows us to do fancy things. Client context, what does it allow us to do? Client, RPC client context, here it is. It has, what does it allow us to do? It actually allows us to receive partial results for streaming RPCs. It allows us to wait until it is done. It allows us to wait for a specific serde message, which is not useful in the Python world at all because there's no typing. And we can query if the RPC is already done, and we can cancel the RPC. So for now, the only thing that's really interesting for us is this wait, I would say. The question is if we want to wrap that immediately. I don't think we want. For now, let's just say, well, we just wait on this context, and that is actually our result that we get from that RPC, and then we print out this result. And that seems about right to me. So basically, if we have a client, we can now issue a call, and actually this call will block until it is done. And I think that's actually fine for the moment. So let me build that real quick. Failed to resolve, could not find value in serde. So is it maybe it's not in serde, maybe it is actually in serde JSON, something like this. No associated item new. Documentation, create serde JSON. This is serde JSON, and we would like to have the documentation. And what is JSON? No, that's not at all interesting. Not at all interesting. There must be something like a value in here, and I don't remember how you actually create a new value. A new empty value. Oh, it's actually, oh cool, it is an enum, so I can just say, well, this is Gerdes JSON value null, right? Ah, works, wonderful, wonderful. And cannot borrow immutable local variable context as mutable, right? So let's make it mutable. It's ours. We can do whatever we want with it. Good morning, Princess Rika. Yes, you're right. You missed most of the stream. So what should happen now, actually? So if I launch this one, what should happen? Ah, that was exactly what I was not expecting. There is a typo. Right. And is that what we were expecting? I think it is actually. Let me have a look. So we connect, we register the RPC here, and then the other client actually calls the RPC, and then the RPC gets called, foobar, right? That is actually the arguments that we pass to the RPC, so that works, and we also get the result back. Oh, perfect. It's all working. It's all working. So how far into the stream are we? So we ran for 20 minutes. Today I want to really keep the 30 minutes because I have an appointment directly after stream. So we cannot go for much longer. So I'm thinking what we can implement. So probably let's move this context wait call. Let's move that over into Python land. And I think to do that best, we probably want to, we need a new function that is basically, it's called Swiboe. It doesn't take a client, it actually takes an RPC context and it waits on this one. So it takes a client RPC context. So what's different about foo bloop? I've been using foo and bloop for the last 15 years. They are very good variable names. Very expressive. This is the RPC context, right? And what do? We actually wait on it, and what do we return? I'm not sure yet, so let's leave it like this. Leave it like this. So in this case too, we actually do we actually consume that? So what happens if we wait on an RPC? It takes the RPC as a mutable pointer, and then it returns the RPC result, which is, yeah, that's expected, right? But it's actually not consuming the value, which is weird, I guess. I mean, no should this not consume the context, right? So the question is basically, if you wait on an RPC, the RPC is done by definition after that. So the object should actually be destroyed through this call, I would say. And I'm not sure why I didn't choose to do that. I choose to do it in cancel, right? You see, cancel takes self by value, so it takes ownership of self, and it doesn't return it. So actually self is destroyed at the end of the cancel function. And I think actually the same should happen for wait. That just feels wrong that it takes it as a mutable reference, and I think it should kill it. So, but I'm not doing that right now because that will lead to a ton of compile errors. So let's keep it for now. But the Python function we actually, or the C function we actually design as if we want to drop it. So in this case, we don't want to transmute it into a reference. We actually want to transmute it into a box of RPC client context, right? This is what I expect. It's actually client RPC. What is it actually? It is client RPC client context. Of course it is. Right? Because it is code that runs in the client and it is an RPC client. Therefore, it is client RPC client context. Wow. And then we get the result. Basically, we pull this one down here. Result, and then we print the result, I guess. I mean, of course, we have to return the result to our C functions eventually, but I'm like, that will be a ton of wrapping again, and I'm not sure yet how we want to do that. So let's keep it for now, keep it like this. Basically here our client call actually gives us something back that we box, and then we unsave mem transmute this so that we can return it into the C world, like so. And this function then actually changes and returns a mutable pointer to A. Here we go again, client, RPC, client, context. All right, perfect. So now our code over here changes too, of course. First, the Swiboe call RPC function, it no longer returns none. It actually returns a pointer to a client context, which, following our type safety approach, is just a void pointer. Yay! And it still takes up, like, the arguments didn't change, so the arguments stay the same. And we have a new function called Swiboe RPC context wait, and that takes as arguments a pointer to a client context and nothing else. And right now it doesn't return anything, which is of course that's not correct. But for now, that's what it does. And basically here we actually expect something like like an RPC context back, something like this. And on this one we can then call Swiboe RPC context, no, Swiboe RPC context wait, and it will actually have exactly the same result. Hopefully. Hopefully. What's interesting about that is, like, you can see how we are actually running against the unsafety of Python again, because here we get this RPC context back, and here it is actually destroyed. But nothing stops us from doing stuff like this again, right? We can just call the same function again, but that will crash horrifically. And that is just because Python doesn't know that you can actually destroy a value by passing it to a function. There's no way of expressing that. So actually, to be 100% correct, what you need to do actually is delete the RPC context here, so that you can never ever use it again. But unfortunately, you can only do that here, right? In the scope where you actually define the variable, you cannot, like, this function cannot delete it for you. That's unfortunate, but that is just the way it is. So let's build, look at the compile errors. Compile errors, compile errors. No compile errors? No, that's unlikely. Shout out to my wonderful wife who's watching the stream and actually brought me tea. Thank you. Here we are, compile errors. Failed to resolve, could not find client and Swiboe client RPC. That's right, it must not be capitalized. It is actually like so. Use of undeclared type name RPC context. I guess that's true too, because we figured out that it is actually called client RPC client context. And it says unresolved name. Well, RPC context is kind of redundant, I'd say. Let's keep it to just context. Building it again, and cannot borrow mutable. Yeah, why is it not mutable? It can just be mutable, right? I can just make it mutable, right? Oh, we don't actually, yeah, that's wrong actually. We must take a mutable pointer here, because we also return a mutable pointer up here. So yes, it should look like this. And I think then we actually can remove the mutable again, maybe. Nope. Okay, then we keep it. I don't care as much. And let's see if this works. Seems to be still working. And now let's go a little crazy here. Actually, let me split. Oh, we don't actually have to split it, right? We basically, but let me be a little more explicit here. Basically, we say we have now the serving client. That's the one that's actually has the, like, registers the RPC. And then we pull this one down and say down here. Here basically we say we make clients, and those clients are, they look like this. Swiboe connect for I in range 10. So 10 clients that connect to Swiboe. And then we say for C in clients for I in range 5. That will be a little messy, but who cares? We say RPCs is a list, and actually it should be contexts. And then we say context append this fun call here. So are you like following what I'm doing? I'm going to create a ton of clients and a ton of RPC calls and just see what happens. So basically we call the RPC on the particular client that we're iterating over right now. And is that actually correct? Yes. And the fun stuff is that we don't wait, right? We run all of these in parallel, and then down here we do something like for RPC in for context in contexts, we wait on the context. And then we actually disconnect all the clients. For C in clients, Swiboe, disconnect, client. Huh? Let's see what happens. And it seems like it just worked. No errors. A bunch of calls, probably 50. Who knows? Let's get that into the arguments. That is now like a number, and that number is actually so this is the, let's have an index for the clients, and we enumerate over the clients, and then we can say basically we have let's do it like this. We say we have num is 0 here, and then we can say, well, num here is num, and then we increase num by 1. Done. And here we actually remove the sleep 1. We just run this once, and then we're done with like we finish our, like, we disconnect from the server. We just see if that works, and it goes rather quickly. And actually let us just return here an empty object for now, right? I'm not that interested in the result, and we don't print the result here either. So I only want to see the calls. And it seems to be working. Let's increase the numbers a little bit. Let's say we don't want 10 clients, but we want 50 clients, and we want each of them doing 100 calls. And yeah, it works. So basically we now have, we can now call RPCs from Python. We don't get the results back, of course. That is actually something that we have to look into tomorrow. So basically here we would like to return results to Python. But we'll look into that tomorrow. Okay, so we're done with the stream for today. I'll leave the stream running now for questions. If there are questions, please post them in the stream chat right now. And in the meantime, I can actually make like commit this. make it possible to call RPCs from Python. It seems like there are no questions. I mean, I think most of what we did today was also pretty straightforward, very similar to what we had to do before, wrapping stuff, returning it, converting it, and I'm rather pleased that it works like without any problems here. I mean, that's already very strong, right? I don't think you will have 50 plugins running at the same time. Do you plan to write language-specific wrappers around the C API? Shriek asks. And yes, that is basically the reason why we built a C API, because then it is easy to write language-specific wrappers. So basically, if you look at this, this is not that's not nice Python, right? In Python, you are not. You actually want to have classes and you want to have very powerful objects that you can deal with more easily. And this is not really Pythonic the way we have to do it. It reads more like C. And of course, that is not how you would present a client object to somebody who's writing a plugin in Python. Actually, this will be wrapped up into something that is easier to use from Python and easier to wrap your head around. And this actually is also dangerous. We already learned that. For example, here where we basically say this Python function should function as a callback from CLand. So we actually have to wrap it up into this C-types object. And we already learned the hard way if we inline that. So basically, if we take it like this and just do something like this, then actually this will crash because Python will delete this object as soon as the function call returns. And then when you try to call something in this object, it will crash. So that's something you need to hide from a implementer because Python people are not used that they need to keep around objects, right? They are used to reference counting and garbage collection. So the wrapper that we write for Python must actually hide that. And once we have a very nice and stable C API client, I hope that people will write Ruby clients and Objective-C clients and JavaScript clients. The idea is basically that you have whatever language you speak, you can implement a Swiboe plugin with this language and it will be as powerful as every other Swiboe plugin out there. Okay, I don't see any more questions in stream. We peaked today at 11 viewers. That's really nice. I think it's a personal record. I think the highest I saw so far was 10. Yeah, thanks for tuning in. Tomorrow we will figure out, oh, not tomorrow, tomorrow's Saturday. On Monday we will figure out how to return values from here, right? And then we have to think about how we actually want to wrap the RPC server context so that we can also handle streaming RPCs and call RPCs from inside our callback functions. Because we cannot use the client object because it is not thread safe, right? We cannot basically say something like, oh, here just use the serving client to call, right? Python would allow that, but actually that is dangerous because the serving client is not thread safe. So basically we need to get the context here to actually properly call RPCs. So Shriek, do you speak Ruby? I would really be interesting to see how a Ruby client looks. Shriek just volunteered to writing a Ruby client for Swiboe. I think once we're done with the Python client, which is maybe another week or so, there's nothing stopping you of writing a really nice Ruby client for that. And I would be thrilled, right? Right now, so many people are using Vim for writing Ruby on Rails, and they only have Tim Pope, it seems. It seems like Tim Pope is the only person able to write Vim plugins for the Ruby on Rails community. Okay, that's it. Thanks for tuning in. See you people tomorrow. No, see you people on Monday. Have a nice weekend. Bye.